In section 7.5, we're going to learn to do what's called solving a right triangle. So what it means to solve a right triangle is that you need to find all the measures of the missing sides and missing angles. So if we go down to example 1, you can see that we know we know two angles. We know one of the angles is 73 degrees, angle A is 73 degrees, and angle C is 90 degrees because there's a box in the corner. What we don't know is what is angle B. If you study the sides, we can see that one of the sides is 7, but there are two sides that we don't know. We don't know what side AC is, and we don't know what side AB is. So to solve a right triangle means to solve for the one missing angle and the two missing sides. So how will we actually do that? Well, there are 4 ways that we have learned, 3 of them in this chapter and 1 of them in semester 1. The 3 things we have learned in this chapter is you can use the Pythagorean theorem to find a missing side as long as you already know 2 of the 3 sides. So if you know 2 out of the 3 sides, then use the Pythagorean theorem. Another way we can find a missing side is to use the trigonometry. How would we use trigonometry? Well, if we know one acute angle, which we call the reference angle, so not the 90-degree angle, but one of the acute angles, if that has been labeled for us, and we know it only one other side, then we can use trig. So if you look at the trig equations, there really are 3 places you plug in numbers, for the angle and then for 2 sides. So each equation has 3 places you could plug in numbers. And so I've just highlighted those. So if only one of those places is a variable and you know 2 of those 3 things, then you can use trig. It's basically the same thing for the Pythagorean theorem. There are 3 places you're plugging in numbers. If there is only one of those numbers that you don't know and you already know 2 of them, then you can use the Pythagorean theorem. So this is kind of a basic rule of algebra. If you know 2 out of the 3 things, then you can use that equation. If 2 of the 3 things are missing, then you cannot use that equation. You cannot have more than one unknown in an equation. Now, if we're solving for missing angles, we can either use inverse trig or we can go back to semester 1 and use the fact that in the triangle, if you add up all 3 angles, they should add up to 180. So in option 3 and 4, those are the ways that you can solve for missing angles. So if we go back to that example 1, we said there was 1 angle missing and 2 sides missing. So let's start with the first thing they're asking for. They're asking for angle B. If you look at that triangle, again, we've already talked about this. You know that one of the angles is 73 and one of the angles is 90. So you already know 2 out of the 3 angles. That means only 1 angle is missing. So we're going to go and use option 4 up above where it says all the angles in a triangle should add to 180. So we know that if we take 180 degrees and subtract the 90 degrees and the 73 degrees, we would have the third missing angle, which would end up being 17 degrees. So we can use the fact that all 3 angles add to 180 because we're only missing one of the 3 angles. When we go to solve for AB, let's put an X on AB. If you try to use the Pythagorean theorem, that won't work because you also don't know side AC. So again, always keep in the back of your mind that in the equations up above, you have to know 2 out of the 3 missing things. I only know 1 of the 3 missing sides. I only know that one of the sides is 7. That means I cannot use the Pythagorean theorem. But if we look at trig, look at what I've highlighted there. You need an angle and 2 sides. I have an angle in one side, which means I'm only missing one of those things. So if you're only missing one of the 3 things, that's the equation you should use. So I know I should be using trig equations. We know every time we use trig equations, we should label opposite, adjacent, and hypotenuse. I always start with the hypotenuse, which is across from the 90. So the x is my hypotenuse. And then I look at the sides, and I label my 2 legs either as adjacent or as opposite. So if you draw those arrows, again, go to the middle of the side. The shorter arrow will be pointing at the adjacent. The longer arrow will be pointing at the opposite. So the 7 has the longer arrow pointing to it. So it is the opposite side. I'm not even going to bother labeling this adjacent side because there's nothing on it anyway. There's no variable. There's no number. So I'm not going to bother with that for right now because I'm focused on solving for A, B, where I put the X. So I know that it's the sine equation I'm going to use. So the sine of 73 equals the opposite leg, which is 7, over the hypotenuse, which is x. The variable's in the denominator, which means it becomes a division problem. So I have 7 divided by sine of 73. And if I put that in my calculator, I get a bunch of decimals. So I'm going to write a couple of them. And I'm always rounding to the nearest tenth anytime I'm dealing with sides. So I would cut that off at the tenths place, always looking to the number next to it to see if I should keep it 7.3 or make it 7.4. Since there's a 1 next to the 3, I'm going to keep it 7.3. All right, now at this point, I still have one thing left to solve for. I should solve for AC. Now, AC is another missing side. So you have an option here right now. You could either put a variable called y, because I already have an x. I don't want to use the same variable. Or I could erase everything. I would erase everything and start fresh and put another x right here for the AC. It would really be your choice. So do you want to erase everything and start fresh? Or are you okay that there's already an x and you're going to call this a y? Now, I think either option is fine because we have done problems where we had both x's and y's. So I don't think that should throw anybody off, but it really is your choice. So if we focus on the y and ignore the x, in fact, I am going to erase the x for a minute. We want to look at what's been given in relation to the 73. So we have that, again, if we point to the two legs, we have an adjacent leg and we have an opposite leg that have labels on them. This time, notice I'm ignoring the hypotenuse. There's no label, there's no variable on it anymore. And also there's no number. So it's not important when I go to solve for AC to look at the hypotenuse. All right, so I have an adjacent and an opposite. That's a tangent equation. So the tangent of 73 equals 7 over y. Remember TOA. Again, it'll become division because my variable's in the denominator. Talked all about that in section 7.3. So we will take 7 and divide it by tangent of 73. We will get many decimals in our calculator. I'm going to write a couple of them. And we will round to the nearest tenth like we always do with sides. So if I cut it off at the first decimal place, I would keep 2.1. I would not round that 1 up because there's a 4 next to it. All right, so that's how you solve a right triangle. You figure out what from the 4 options above can we use to solve for the missing sides and the missing angle. Now, if we compare example 1 to example 2, I do not know one of the acute angles. If we look at example 1, I knew one side. I knew that we had a 90-degree angle, which of course is kind of given in this chapter. We are using right triangle trig. We are using the Pythagorean theorem, which only works on right triangles. And so the right angle is great, but it doesn't really help us define anything other than the hypotenuse. So if we look at example 1 again, we see we have one of those angles that's called the reference angle, and we have one side. In example 2, we do not have a reference angle, and we have two sides. So I like to start with whatever the first thing they're asking for. The first thing they're asking for is what is the measure of angle A? So right here, what is the measure of angle A? So I'm just going to put a variable on angle A. I'm going to put an X, and of course I'm putting it inside because variables or angles are always labeled on the inside. And so if we go up above and we say, okay, what are the options? And they're the options in blue. You can either use inverse trig, or you can use the fact that angles in a triangle add to 180 degrees. But like I talked about at the beginning of this video, if you don't know 2 of the 3 things, then you can't use that fact. So if we come down here and we try to say, okay, I'm just going to add up all the angles to 180, that's not okay. We only know one angle. We only know one of the angles is 90. So option 4 is not going to work. We can't just subtract from 180 because we only know one out of the 3 angles. So if you think about inverse trig, let's go back up to inverse trig. You need to know an opposite leg or a hypotenuse, or an adjacent leg and a hypotenuse, or an opposite leg and a hypotenuse. If you do that, you can solve for that missing angle. Well, that's exactly what I know in example 2. If I label what I know, I have both a hypotenuse across from my 90, and I have an opposite leg. I can use sine or inverse sine actually to solve for missing angle A. So my angle X is equal to inverse sine of my opposite leg, which is 8, over my hypotenuse, which is 13. If I put that in my calculator, again, I'll get a bunch of decimals. Let me write a couple of them. 37.979. We're going to round to the nearest whole number like we've been doing in this chapter for angles. So we're going to cut it off right here. And we're going to round that up to 38 degrees because there's a 9 next to that 7. Now we could use inverse trig again. But what it would be easier is to say, hey, now I know that angle A is 38 degrees. So now I do know 2 out of the 3 angles. So if I take 180, subtract 90, and then subtract 38, I will get a missing angle of 52 degrees. So I know angle B must be 52 degrees. All right, now let's switch over to AC. And sometimes, again, it's easiest just to erase everything you've done so far because the picture gets a little bit too busy and to start over. So if I just put an X on AC and say, what would I do if the picture looked like that? And let's go up above. That's a side. So if we looked at the stuff in red, we can either use the Pythagorean theorem or we can use trigonometry. But which one do we actually have enough information to use? If we come down here, we know 2 of the 3 sides. We do not have a reference angle. If we do not have a reference angle, we're not going to be able to use trigonometry. And so we're going to use Pythagorean theorem. So that's the hypotenuse squared equals leg squared plus leg squared. So my hypotenuse is 13. My 2 legs are the 8 and the x. So I know that x squared plus 8 squared, which are my 2 legs, equals 13 squared, which is my hypotenuse. X squared plus 64 equals 169. Subtract 64 from both sides. We end up with x squared equals 105. Square root both sides so you can get that x squared to just be an x. And at the beginning of the chapter, we asked you to simplify the radical, but in this section, we're asking you just to convert it to a decimal. So again, there will be a lot of decimals in your calculator if I keep a couple of them. And then think about the fact that in this chapter, I've always asked you to round to the nearest tenth. This would end up being 10.2. We would not round that 2 up because there's a 4 next to it. All right. Now in example 3, we could certainly do everything we've done in example 1 and 2. We could analyze what do we have? Do we have enough to do trig? Should we do Pythagorean theorem? And we could do it with trig, and we could do it with the fact that angles add to 180. But we could also hopefully notice this one special. If you have a 60 and a 90, we know that the missing angle, if we subtract the 90 and the 60 from 180, the missing angle is 30 degrees. So if you still have your special right triangles memorized, you can just use your special right triangle relationships. So your special right triangle relationships say, let's get that 30 in there, that we have a short leg called 11. So that means the long leg, which is across from the 60, is 11 root 3. And the hypotenuse, which is across from the 90, is double your short leg, which is 22. So AB is 22, and AC is 11 root 3. And if you want to convert the 11 root 3 to a decimal, you get about 19.1 if you round to the nearest tenth. Now, if you don't have your special right triangles memorized, you can actually use trig. So if we're solving for, let's just pick a side. Let's pick AB. If you're solving for AB, you can use trig because you have that reference angle is 60. X is your hypotenuse because it's across from your 90. 11 is your adjacent because it is next to your 60. So you can say to solve for AB is the cosine of 60 equals adjacent over hypotenuse, which is 11 over x. It's in the denominator, so we can swap it with the trig and get it to be 11 cosine of 60. It would become a trig problem. And if you put this in your calculator, 11 divided by cosine of 60, you get exactly 22. So if you have your specials memorized, you could save yourself all of this work here. You wouldn't have to do all of this trig work here that I just highlighted in yellow. You would simply know it was the 22. But either way would get you to the right answer, so whichever way you want to do would be fine with me. Same with AC. If we put a y on AC, or even if you erase everything and start over, y is the opposite leg. 11 was the adjacent leg. We can say the tangent of 60 equals opposite over adjacent, y over 11. To solve that, we would multiply both sides by 11. We'd do 11 tan of 60. And this would again be about 19.1. So specials, memorizing those specials from the beginning of the chapter can save you a lot of time. But if you don't have them memorized, you could also just do all of this trig work and still get the right answer. All right, so that's how you do what's called solving a right triangle. You look at your right triangle and you ask what angles and what sides are missing. All triangles have 3 angles and 3 sides. If you're missing a side, either use Pythagorean theorem or trigonometry. If you're missing an angle, you either use inverse trig or the fact that angles add to 180 degrees. And always in the back of your mind, think about the fact that if you're trying to use any of these equations, you have to know at least 2 out of the 3 things that I have highlighted.